Hi there. Okay, so I guess if you're watching this right about now and it's actually class time, I'm in Vail presenting what we're doing with the lecture capture in this class and in my other classes. So hopefully it's going well. And hopefully this format works out for you, so basically we can kind of stay on pace. Now, we'll be back on Tuesday, so the following Tuesday for you guys. So if you have questions, we'll be able to ask then. Also, email me if you have some questions, and I can get back to you that way also. Now, I know we normally open the class with working some problems. So I'm going to just work some problems that I think might have given you trouble. And we'll focus in mostly on some of the even ones, and might do a few odd ones if there's something in particular there. So let's take a look at, oh, that's not what I wanted, some questions from there. Okay. So, first one I think we'll look at together is just some basic factoring. So if we look at number 24, where it just asks us to factor completely. So we have 24. So the first one we'll look at is 24. And 24 gives us 8a cubed plus 14a squared plus 3a. And the first thing we're going to want to do is factor out a GCF. We want to make this simpler for ourselves. So we need to factor out the GCF, GCF, which in this case is an A. Because all of the terms have an A, and the smallest exponent is A1, I'm going to factor out an A out of all those. So A leaves me A squared plus 14A plus 3. My leading coefficient is not 1, so I need to do the full AC, big AC. So my AC and then the B. My AC, 8 times 3 is 24. And I'm looking for something that adds or subtracts to a positive 14. So what are my factors? 1 times 24, 2 times 12. So I have a positive 2 plus 12. So now I'm going to break down my 14a into 2a plus 12a plus 3. And I still have an a squared. That was a positive 2a. And this other a, that GCF, I'm just going to keep on the outside for right now. You just have to remember to kind of carry it along. So we look at the front group, and then we'll look at the back group. And what can I take out of the front group? On that front group, I can take out a 4a. Oh, can't take out a 4a, too much. How about a 2a? And then I'll have what? 4a 4a plus 1. In the back group, I'm going to take out a positive 3. Remember, I've got to get my parentheses to match, so I kind of know that if this is going to work, I have to have 4a in front and a 1 in the back. So that is 4a plus 1. My common term is the 4a plus 1, so I can kind of factor that out. And I'm going to have 4a plus 1. I bring the other two pieces together to make my next term. 2a plus 3. And I need to bring down that other a. That has to be part of the answer also. I can't forget that. So I have a times 4a plus 1 times 2a plus 3 for number 24. And let's see, this was 6.3. Now let's see if I can look at another one. If we go down into 34. Now, with 34, is negative x squared plus 4x plus 21. Now, it's going to be a lot easier if we can get that leading coefficient to be positive. So how can we do that? If we factor out a negative 1, my leading coefficient becomes positive. So I have x squared. Whoop, that would be a minus 4x because all of the signs change. Minus 21. Now I can factor. But my leading coefficient is just 1, and it's a positive 1 now. So I can do the small AC. All I need is something that multiplies to 21 and adds to negative 4. So I have 21, negative 4, and I can go right to two parentheses. Since my leading coefficient is 1, I don't have to worry about the middle term, that fourth term. So this is just the small AC that I need to do. So I know my front's going to be x and x, and two numbers that multiply to be 21, and I could subtract or add to make 4. So 1, 21, 2, how about 3 and 7? Because I could do what? Equals 3 minus 7. So I know I'm going to have a negative 7, a positive 3, and on the outside there I still have to bring down that negative 1. So I have a negative 1. So, skinny AC. Okay. When the leading coefficient is 1, small AC. Or we can go just the two parentheses and not have to worry so much about that middle term. And 38. we have 36x squared plus 55x minus 14. And this one's going to take a little bit of math because we have to look at that big number. We have to look at that AC. So my AC is what in this case? 36 times 14 . And I get 504. My B is going to be positive 55. Well, I can start out with 1 times 504, but notice how if I add or subtract, I've got a big number. I've got to get something that's a little bit closer. So let's scoot up into 504 divided by 9. So 9 times 56. Ooh. So notice how I can get what? 65 from that by adding, or into the 40s. So, how about 504 divided by 8 is 63. So 8 times 63 is going to give me 55. So 55 equals 63 minus 8. My leading coefficient is not 1. I had no GCF to factor out, so I have to go ahead and split the middle term to get 4 terms so I can factor by grouping. So I'm going to have 63x minus 8x minus 14 and 36x squared. And that was a positive 63. So my front group, my back group, and what am I going to factor out in the front? I can factor out what? A 9? So 9 times, how about a 9x? Both of them have an x. So 9x is going to give me 4x plus 7. And out of the back group there, now notice how I want to get a 4x plus 7. Notice the sign. That's positive in front, negative in back, so I need a sign change. I have a negative and a negative. I need both of them to be positive. So I know I'm taking out a negative. To get 8 to be 4, I'm going to have to take out a negative 2. So if I take out a negative 2, I wind up with 4x plus 7. My parentheses match, so I can bring the terms together, factoring out basically the common 4x plus 7 and 9x minus 2. And if I FOIL that together, then I'll have the same thing that I started with. Now, I know some of these do get kind of big, but use a strategy. I mean, you don't have to do them all, but start to think about, what is the difference or what is the sum that I'm looking for in that AC? And that'll help you a little bit in getting some of those big ones done. And let's see, some of the others. Now, there was a group in there that had perfect squares. So if we look at 48, we have 3y squared minus 6y plus 3. Is there a GCF that we can factor out? Yeah, I have a GCF of 3. So I'm going to take the 3 out. And I have left y squared minus 2y plus 1. The front and back are perfect squares, and it tells you that in these problems. So in the instructions up on the top of the page there, it says these will be perfect squares. And we know that square root of 1 is 1, and the square root of 1 is 1. So I can go right to 1 parentheses. Remember when I was talking about the reverse of the special product? Well, with the front and back square roots, I can go straight to here. The only thing I'm going to have to do is check the middle term. So let's do it this way. Let's not even put the square in yet. Square root of the front, square root of the back, square root of the front, square root of the front, square root of the back, square root of the back. The middle sign is negative, meaning that both of these are going to have to match. They're both going to be negative, because a negative times a negative is the positive. All I need to do is check my middle term. Negative 1y, negative 1y. And I get negative 2y. The front's y squared, the back's a positive 1. I factored out the GCF of 3. So that was the perfect square on those. If we skip down a little bit into number 60, to write it as 3 times y minus 1 squared. Since both of these factors are the same, we need to write it in the form of a square. Let's take a look at another of those perfect squares. Number 60 is a perfect square, where the front and the back, the square root of 1, or the square root of m, are perfect, and the square root of 100 and the square root of n are perfect. So we know the front's going to be m times m. The back's going to be the square root of 100 and the square root of n. So how about 10n, 10n, right? Square root of 100 is 10, square root of n squared is just n. All the signs are positive, so these two have to be positive. With both the parentheses being the same, I write it as m plus 10n squared. And they get a little bit bigger and a little bit ickier. But if we look at number 7, okay, and then let's take a look at 66. 66 does not have a leading coefficient of 1. Is there anything we can factor out of 66? And they all have a x in common. So we know that we can factor out the GCF that includes the x. So we have a GCF. And we know it's going to have a x, because that's the smallest exponent of the common variable. And we can factor out a 2 out of all the coefficients. So if I factor out 2x, I end up with 3x squared minus 28x plus 8. Leading coefficient still isn't 1, not perfect squares, so we have to work the AC. So AC and B. So my AC is 24. My B is a negative. Oh, shoot. Not 28. I didn't divide that by 2, did I? About 14. That'll make it turn out better. So we have a B of negative 14. So if we start doing our factors, 1, 24, 2, 12. So we know negative 14 can equal negative 2 and a negative 12. Negative 2 minus 12 will give us negative 14. So that's what we're going to split that into. So I have negative 12x and a minus 2x plus 8 and 3x squared. And I'm going to just keep that 2x hanging around out front. Got my two groups. Front group and a back group. Of the front, I can take a 3x, and that's going to give me x minus 4. Of the back, I'm going to take what? Remember, I want an x minus 4, so I can take out a negative 2. That's going to give me x minus 4. Bring the two together and take out the common factor. So my common factor is x minus 4. Bringing the other two together, I have 3x minus 2. And I bring down my 2x that I factored out earlier. So my three factors in 66 here are 2x, the quantity 3x minus 2, and x minus 4. In number 78, we have a little bit bigger numbers, but they're still pretty doable. If we want to look at the AC, and in this case we kind of have to, the leading coefficient is not 1, nothing to factor out, so my AC is going to be 54 times 8. And I wind up with a 2, carry a 3, 200 and, oh, not 200, about 43, 432. So I know my AC is 432. I know that my B is a positive 39. And 1, 2 probably isn't going to do much. Does 3 go into there? Yes, 3 goes into 432 because I know that 3 plus 2 is 5 plus 4 is 9. So 3 goes into there 144 times. And 4 goes into there what? 432 divided by 4, 108 times. Two, 9 actually goes in there because 2 plus 3 is 5 plus 4 is 9. 9 goes into there 48 times. So there's our combination. 9 times 48 because 39 equals 48 minus 9. So I know the middle's breaking down into 48 AB plus, oh, how about minus? So it's a negative 9. Negative 9 AB minus 8b squared. And in front we have our 54a squared. And that was a positive 48. Our front group, we take out what? Well, we know we're going to take out a A. And what's a common factor between 48 and 54? Well, we know they're both divisible by 6. So, let's see. Oh, how about even, let's see, would 18 work on both of those? So, no. So, I think 9 is probably about the best we could do. Let's try 9. What do we get? We get 6a squared. Oh, 9 doesn't work. Doesn't go into 48 evenly. So, 6 is probably going to be about it. So that would give me 9a plus 8b. So if I get a 9a, oh, I already have a 9 and an 8b. I have a b and b squared, though, that I need to take something out of. And notice I need both of the signs to change. So in the back group here, I'm going to take out what? A negative b. And if I take out a negative b, what am I going to have left? Signs change, so I have a positive 9a plus 8b. And my parentheses match. So when I bring those together for my answer, my common factor is 9 plus 8b times 6a minus b. And I can FOIL those back, and they should check out to right where I started. And let's take a look at 81. Is there a GCF? Is there something I can take out of everything there? No. But what do I notice about the front and back term? And if you don't catch this, you can always use the AC method. But notice how square root of 9 is 3, square root of 16 is 4. I can go right to kind of the special product, is what we used in the last section. The last chapter we talked about special products. This is that special case where it's going to factor. So I'm going to factor to 2, and I'm going to have what? 3x, 3x. The middle's a negative, so I have a negative 4y and a negative 4y. You know, this is worth checking. All we have to do is look at the middle term now, and if it works, fine. If not, then we do a full AC. But if we notice we have a negative 12 xy and another negative 12 xy, so my middle is negative 24 xy, which is what I wanted. So with the middle working, and I know that the front and back were perfect square roots, that's all I have to do. And number 90. Is there anything we can factor out? Yes, there is a GCF. And that GCF is just y. So when I take that y out, I have left y plus 12y squared plus 36y. Whoa, hang on, I forgot to take out some y's, didn't I? So, oh, I copied the problem wrong. Let's look at 90, y cubed. There, now that works. Y squared, y, and 36. We take all those out. Y cubed, y squared, 36y. Okay. Leading coefficient is 1, so I don't have to worry about that middle term. The leading coefficient is 1. I can just work right with the trinomial. I know my first term is going to be y. My second term is going to be 6. Ooh, I actually could have done this as a perfect square also, looks like. They're all positives. Check my middle term. 6y. 6y gives me 12y. Okay, so looking good there. So my answer is going to be y times y plus 6 squared. And now let's look at this section then. So we're going to continue factoring, and we're going to do some more factor by grouping. So notice how we have 4 terms, no common GCF. And really think about it as just the last half of the AC method. We already have our 4 terms. So when I go in, And I have my front group. I can take out a z. And I'm going to have z plus 10. In the back, I take out a negative 7, and I have z plus 10. My parentheses match, so I can bring things together. Z minus 7 comes together. Z plus 10 is factored out. I have no common GCF. Nothing to take out of those, so I just have to use it just like it sits. So I'm going to take out an x squared out of the first group. Common variable, smallest exponent. What's left on the inside? 5x squared minus 3. So I know that's what I'm going to be shooting for in this next group. So I take out a 5, that's what's in common, no common variables, and have a 5x squared minus 3. Bring things together. X squared plus 5, the common factor, 5x squared plus 3. Now, in number 10 here, it's just kind of worded a little differently than what we've done before, but really what it wants you to do is just think about the AC method. Find two numbers whose product is 8 times 3 and whose sum is 14. So we look at our factors. The factors of 24, 1 times 24, 2 times 12. Ooh, from 2 times 12 I can get a 14. So we know that 2 times 12 is going to be our answer. And then write 14x using the factors from part A. It's kind of the same thing we do when we're doing our AC. We're simply going to write 2x plus 12x equals 14x. Now, by now you guys are saying, oh, we've been doing this for a while. Yes. This chapter just allows us really to look at the factor by grouping and really make sure that everybody understands it. And then we can actually factor by grouping, where we break down into 4 terms, and we have the first group and the last group. Take out the 4x, we have 2x plus 3, and all we can do on the second group is take out a 1. Remember, 1 is kind of your default. Factor out 1 if nothing else comes out. And then I'm going to bring those together, 4x plus 1, my common factor, 2x plus 3. Factor each trinomial completely. Well, we have to get that fourth term in this case. Our leading coefficient isn't 1, no common factor, they're not perfect squares, so I do an AC. A times C is 20. I'm looking for a negative 9. So my factors, which one's going to work? Well, I can probably have a negative 4, negative 5. So that's going to work. So I use the fact that negative 9 equals negative 5 minus 4. So I used a negative 4, negative 9. Brought down my other two. First group, 10x squared minus 4x, factor out of 2x. On the inside, 5x minus 2. On the outside, factor out a negative 1, because I need the sign on the negative 5 to change to a positive 5. I need the positive 2 to change to a negative 2. Nothing in common other than a 1 and a sign change. So I have 5x minus 2. Parentheses are the same. So I have 2x minus 1, 5x plus 2. No GCF to factor out. Are they perfect squares, front and back? No, not so lucky. So I use my AC. But notice before I used the AC, I needed the order of the terms, right? I had to move the x squared to the front because that is the A term. The B term is by x. The one by itself is the C term. So what's my AC? 100. What's my B? 20. And that's a positive. What are my factors? Well, I think everybody can see we're going to go right to a 10 times 10. Because I know that 20 equals 10 plus 10. So that's going to break down into two parentheses. And now I have perfect squares. So I could do a full AC. Or, I just have the square root of 25, square root of 4. So I know my first is going to be 5x. I know my last is going to be 2. Everything's positive. And I just need to check the middles. 10x and 10x is 20x, and rewrite with a squared. Then in 29, factor out of 2. Get it a little bit simpler. My AC is 72, looking for a negative 17. Factors of 72, a whole bunch of them. Where am I going to get a 17? 18, 22, yeah. 8 times 9, right there at the bottom. So I know 8 times 9 because a negative 8 minus 9 is the negative 17. Bring down the other terms. Remember to keep that 2 on the outside, somewhere in there. Out of the first group, I'm going to take an 8y, which leaves y minus 1. Out of the second group, I'm going to take now I need a sign change. Notice how that's a negative in front and a positive. I need that to be a negative. So the only way this is going to work is if I have a sign change. So I'm going to have to take out a negative 9. Then I have y minus 1. My two factors, y minus 1, 8y minus 9. But what's missing? Yeah, we have to remember to bring down the 2 on the outside. That first initial GCF has to be brought down. Now, I've seen some students too, they'll write it on this side so they can remember to put it back in. You can write it on either end, but it has to be part of the answer, because that is one of the factors. That's it for the first part of 6.4. And we'll pause a moment here and go ahead and click on the next video link if you would like to continue on and see the next one.